Hello everyone out there in Zoom land, my algebra students. Set builder notation, this is starts off 10.4, starts off with interval notation and has compound inequalities in it. And so we're going to be looking at those, probably going to go into 2 videos, quite frankly, a little bit longer. We have seen set builder notation before. Remember, it was this fancy notation like this: the set of x such that x is less than or equal to -2. So that's set builder notation. I called this informal, my own name for it, set notation. Some people call it no notation. They haven't used any notation on this, whatever. And so, but I say that, okay, I know what they're talking about, and they've asked us to solve problems, and they have put it in that form in our book. They've also put them in this form in our book. And so sometimes they use what I call this informal set notation, and sometimes they use the more fancy set builder notation. Either way, I'm good with it. They've asked us to graph this now on a number line using open and closed circles. And that's what we have done. Because it's, we remember, because it's greater than or equal to, or less than or equal to, it's going to be a closed circle. And I meant to have that straight underneath it, and it somehow didn't get that. So this goes with a closed circle, whereas greater than and less than go with an open circle, right? So we've seen that. We've even seen that recently. In my memory, we saw that in the last part of chapter 9. And so here I'm going to be on my number line here at -2, and I'm going to have a closed circle because it's or equal to. And this says that x, the solutions, are smaller than -2 or equal to -2. So the solid is what made it equal to -2, and then we're going this way to be smaller than -2. Oops, I got on the wrong one here. This is the open closed circle one, and this one they were asking me to use brackets and parentheses. What they do when they have parentheses, that goes when you have open circles, and the brackets go with closed circles. And so here I'm going to change this closed circle into a bracket. So a square bracket like this. And then this line comes right up to it. And I don't care which one of those notations that you use, but I care that you can know that this and this are the same. Because in the end of chapter 9, when they asked you to graph things, they also asked you to graph these things in chapter 1 and some other place too. We've done this a few times, graphing them. They always used open and closed circles. And now they're going to use this bracket and the parentheses. So that's what they're going to have in the back of the book. I don't care which one. They're both good. And so the reason they're using and showing you the bracket and the parenthesis is because they want to show you interval notation. And interval notation, I think, is really, really useful. And they're going to ask us to put our answers in interval notation. Actually, they ask some answers in set builder notation, some answers in interval notation. And so they ask for both. So my interval notation is left to right as you read it. So left to right as you read it. So my solutions start down here at the end of the number line. And at the end of the number line, we usually refer to that spot, the very end, which you really can't get to. Can you walk this way as far as you can? Even if you walked all day, you would never get to the end. And so, we call that place -infinity. So my solutions go from -infinity, so all the way from the end, as far to the left as you can go, -infinity. And then, and if I was to start walking and walk my solutions, I would go from as far as you can go, -infinity, left to right, like you read, to -2, comma, -2. But that's not all there is to it. So this is where my solutions start as I go left to right, -infinity, and this is where they end, -2. but that doesn't tell me if it includes -2 or doesn't include -2. And so there's where a little more notation goes, and that's where you put the bracket, because that says including -2. Whereas if I put a parenthesis, that would say not including. You get right up to, but not include -2. So that's what that closed circle says, is that if I was going to tell you what the solutions were, -2 would be included in my list of solutions. There would be as many things as I could name in the list, but -2 would be in the list. Where if this was open circle, there would still be as many things as I can name in the list, but -2 would not be in that list. And then I need something over here, and you always put parentheses with negative infinity and positive infinity. So you always put parentheses with them because you can't get there. And so it's I could walk all day and I'm not going to get to the end of the number line. And so that's the reason. So every time that you have negative infinity, it'll be a parenthesis. And every time that you have positive infinity, it will be a parenthesis. Anytime that you have a number here, it'll be a parenthesis or a bracket, depending on if it was greater than or equal to, or just greater than and less than. So the or equal to matters, right? So that's kind of the idea there. And so whether or not you have a parenthesis or a bracket doesn't go with the infinity. Okay, so we're going to try one more here. That was problem 2 out of your book. This is problem 8 in your book. Write it in set builder notation. The set of x such that x is greater than -7/6. And use open and closed circles. So -7/6 is somewhere right here, -7/6. And it's an open circle because it's greater than, right? Not greater than or equal to. And the things that are larger than are this direction. That doesn't look very neat handwriting. It's because my pencil is really dull. And so just doing my best at all times. Okay. And with parentheses and brackets, all that you do is that you change that open circle right here that you had. You change it out. Parentheses go with open circle and brackets go with closed circle. So since I had open circle right here, that eraser is not going to work. That pencil's been too long, too old, and so you won't be able to use that to do that. So I'm going to have parentheses right here. A parenthesis. So oftentimes people try to make it look like it's half. Half a parenthesis and half a bracket, so you have to really make sure that it's clear what you've got. And then in interval notation, this time as I'm going left to right like I read, I get to the solution at -7/6, comma, and then I go all the way, right? I'm now saying I'm in the solution, all the way to positive infinity, right? And infinity always goes with parenthesis. And this one, because it was open circle or because it was greater than, goes with parenthesis as well. And so, and there you have it. And so that's interval notation. We did a lovely job on it. Then the next problems are the union of sets. And they say that the word or corresponds to the union of sets. And the symbol they use in your book is this symbol like this. And the symbol says union. If you're thinking that it looks like a U and says union, I don't think that's such a bad thing to think, right? And so, and it means or. And the definition is the union of two sets, A and B, is the set of all elements that are either in A or in B, and is denoted by A union B. And so we're going to do one, and then we'll come back on the intersection of sets. And so here's a union one. And so basically, when you have like number 18, what they're asking you is to put all of the elements together. A union B includes all elements that are in A and all elements that are in B. And you wouldn't write anything twice. So A union B would equal, A says it'll have a 5 in it and a 10, and B says, yeah, I agree on the 10, and a 15 and a 20, and B says, I agree on the 20, and B actually didn't add anything into the mix. It didn't say, there was nothing. A union B in this case is all of the elements of A. There was no element in B that wasn't already in A. And so there's A union B. Whereas this example right here, there are elements in B that are not in A. And so A union B puts all of the elements together. All of the elements in A and all of the elements in B are in that same set. So my answer could be anything in A or anything in B. And so that's kind of the story. There's times when we have the word or going when we go to the bank. And so if you go to the bank and you have an account that has two people's name on it and the word or in between, and the union is the or value. And so what that means to the bank when you have that is that either person can come to the bank and withdraw all the money. And so if I have an account that says Donna or Tyler, Donna can go down to the bank and take all of the money out of the account without Tyler's knowledge. If it has the word or on it, Tyler doesn't have to be there. And so I kind of think about the elements of the set as far as, are they part of the union? All of the guys here are part. All of the guys here are part. The word and means something different at the bank, right? The word and means they both have to be present. So if it says Donna and Tyler, and I run down to the bank and I say, give me all our money, they'll say, where's Tyler? Tyler needs to have a say in this too. And so that's the and. And we both have to be present in order to get our money. And so in the case of sets, they both elements have to be present to be in the intersection. And so the word and corresponds with intersection, and the symbol they use is this symbol here. And if you're thinking it looks like an N kinda, it sort of does. I kind of agree with you, and intersection IN, right? And so the intersection of two sets, A and B, is the set of all elements contained in A and B. So you have to be in both. And so both people have to be present, where only one of them has to be present. So 5 did not have to be in both sets. It just had to be in one set in order to be part of the union. Whereas 5, in order to be part of the intersection, has to be in both sets. And it's not, right? And so the intersection is only the elements that are in both. And so that's 10 would be part of the union, and also 20. So you have to be in both. In the intersection, I said union, and I apologize about that. So you have to be in the intersection, you have to be in both sets. So here's my example, and you notice there's no element in my example that they have in common. There is no element that's in both sets where both people have to be at the bank, right? So there's none. We don't have that, and so the intersection then, A intersect B, is called the empty set. There is no elements, right? We would list the elements. Another way that you can say the empty set is you can put brackets like that with nothing inside. And that's another way. So we have these set brackets. So this is the items in the set, and now there's nothing inside those. Okay. Now, the problem with these, but we're going to do the same thing, is we're going to be looking at, do they have anything in common? or and that kind of an idea. But the idea here is I can't list all these out. This is written in interval notation, and I can't possibly list all of the elements. There isn't just 4 elements like there is here, and there isn't just 2 elements like there is here, or 3 in both of these. This is actually infinitely many elements, and if I started listing them all out, it would take all day. So I'm not going to be able to list them out. And in order to find the answer, it's harder to know what the union is and what the intersection is, and that's what they've asked us in problem 24 and 36. So here they've asked you for the union, and here they've asked you for the intersection. But to make a graph of it is really, really helpful. So any item, any element that is in either set is an element of the union. And so you can use open circle or you can use parentheses, your choice. I'm going to use open circle. I like it better. And so this is A. Those are all of the elements of A. Too many to list, but -1, -1.5, -2, -1.7, -1.75, -1.8. I haven't even got out of the ones. You know, all of those are, and so this is A. I'm going to draw B in a different color, if I can find a different color without hurting myself here. I'm getting kind of happy because there's not too much more to go of this semester, and I'm starting to really look forward to the end. I don't know about you guys. So 3/2, this is where 0 is. 3/2 is right here, and that's 1.5 is what it is, so it's a little bit bigger than 0. And it's got the bracket, so I know that it's closed circle, so I'm going to make a closed circle here. And then it's going from -infinity, the solutions for B, all the way here. And then I want the solution to the or, right? That's what the union is the or. And so I'm going to draw that right below it. So all you have to do is be a solution to one. So these items are all a solution to my or, all of these items right here, because they're a solution to both. So you can be a solution to one of them or both, right? There's nothing special about 0. It's a solution to one of them. It's a solution to B, right? I have it drawn in green, and that's solid over the top of it there. And so these things were a solution all the way to 0, were a solution to both. But at 0, it was a solution to 1. But all you have to do is be a solution to one of them. I sometimes say, just as a joke, that it's like being invited to a party where 2 people are sending out the invites. These people decided to choose A, decided to invite the elements -infinity through 0. And B sent an invite to -infinity to 3/2, right? And so 0 is only going to get one invitation to the party from B, but 0 still gets to go to the party. And whereas these items over here, like -1 and -2, are getting 2 invitations from the party. A sent them an invitation to the party, and also B sent them an invitation to the party. But they're still getting to go to the party. They're not getting to go to a double party or anything like that. They're just getting... So there's nothing too special about them. And so this continues all the way to 3/2. And 3/2 is 3/2 invited to the party? And well, yes it is, because who invited 3/2 to the party? B did. And then I'm going to put an arrow on this, and there's my answer as a graph. Anything smaller than 3/2 is part of the or. So this is the graph of A union B. There's its graph. If I want to write it in interval notation, A union B would be from -infinity all the way to 3/2. Now, if you're saying, isn't that exactly B? And the answer is, yes, that is exactly B. I didn't think that would happen. Well, that happened right here on number 18, right? A union B was exactly A. And so that can happen. Does it always happen? No, it didn't happen here, but it can happen. And it did happen here. Okay, so now here they're asking us about the and. And we're going to give a try to do in the and you would do the same setup. So if we hadn't done 24, we would be doing the same setup, which we would be drawing our little graph. There's A. Here's B, solid circle. Okay. So when we do the intersection, A intersect B, or and, you have to be invited by both people to the party in order to attend this party. And so when I start trying to draw the people that are invited by both parties, here, but A invited these people down here, like -7 and -8, were invited by both B and A, because we have that their solutions are both here. So we would be going here. It's where they both are, right? And where they both are, all the way to -infinity, right? Where they both are. And then when we get to 0, is 0 invited to the party by both? Because that's what and means, by both. They both have to be at the bank. And so did both A and B invite 0? And the answer is no. B said, hey, let's invite 0 to our party that we're going to have. And A said, no, I don't really like 0. I don't want to invite 0 to our party. And B said, oh, okay, we won't invite him then. We'll only invite on people we agree on. Whereas over here, they were throwing a party, and anyone A wanted to invite and anyone B wanted to invite got invited to the party. And there were some people that both A and B had in their list. And so they didn't get double invitations, or they didn't get to come to the party twice, but they got to be invited to the party, right? And so this is happening to 0. Is no invitation for 0. So that's an open there. That looks like 0, 0 looks like open, open, right? I mean, it's kind of crazy that it's 0 and then a 0 looks like an open, but it's open there at 0. How about the people, how about the points in between 0 and 3/2? Are they being invited to be part of the intersection, A intersect B? And the answer is no. You have to be invited by both, but only B invited 1, and only B invited 1 1/4, and because this is 1.5, right? And only B invited 1.3, and only B invited half, and so they don't get to come. You have to be invited by A and B. So this is what A intersect B looks like. And if I wrote this in my set notation, this is going to go from -infinity equals to 0. And then I'm going to put a parenthesis because not including 0. Okay, and so we'll try 28 and 40, and then I'll go have my dinner because I hear that my dinner's ready, and this is going to go into 2 videos, I think, anyway. So this is the or, and you draw it and see how they're both the same. So I'll be able to use my same drawing. If you liked, you could do that. If I do that too much, it gets people all messed up. Now 7/3, you kind of have to know its size compared to 9. And 7/3, if you turned it into a mixed number, as a mixed number, it's 2 1/3. If you turned it into a decimal, you might be telling me it's 2.3 when you rounded. Either way, I'm not too particular on that. All I wanted to know is that this number is smaller than 9, so that when I put them on my number line, I'm going to put 9 here, and I'm going to put open, and here is my drawing for A, from -infinity to 9. And then I'm going to do B in the green color. And so 7/2, remember that's 2 1/3. So here, 7/3 rather, 2 1/3. And that one's also open circle. Open, open, open. And it's going this way to infinity. And I want to know, well, what if we were going to have a party, A and B, we're going to have a party and invite people, and A said, here's my list, and B here's my list. You know that, notice that B and A have some intersection in their list, but that's not what we're looking for here when we're thinking about the union. So I want to see who got invited to the party. So did these people get invited to the party? Well, all you have to do is be invited by one of them. And so yes, they did. A invited them to the party. So all of these elements down here were invited. What about 7 over 3? Was it invited to the party itself? And the answer is yes, 7 over 3. All of these are being invited, right? Was invited because who invited 7 over 3? A said, you're part of my set. So anything part of A is part of the union. And then all of these items were in between are part of the union because they're part of both of them. So they can claim A invited me or B invited me. Both of them invited them. 9 got invited by B. So 9 gets to come to the party. 9's part of our union. And all the way, these things all the way, 10, 11, 12 are all invited by B to be part of the union. And so there is our graph. And they do make it look silly in your book like that, and they don't put any numbers on the number line. And so they might put some numbers on the number line. Here, I'll put some numbers on the number line. Here's 0 on my number line. 7 over 3 and 9 and 0 are no more special than anything. Everything is a solution. A union B goes from negative infinity to positive infinity. Another way of writing that is A union B is all real numbers. Okay, so with the same drawing, so I'm going to quickly get up the same drawing. So here was 9, it was open, it was going this way. Here was 7 over 3. It was open. It was going that way. And now we're looking at the intersection. Have to be invited by both. And so as I put my number line here to put the things that are invited by both, are these things before 7 over 3 invited by both? And the answer is no, they're only invited by A. How about 7 over 3 itself? Is it invited by both? Because remember, this is and. Both have to be at the bank. No, it's only invited by A, not invited by B, because it's open circle for B. How about the things in between? Are they invited by both, by A and B? And the answer is yes. This line shows invited by B. This line shows invited by A. So the things in between, open, are invited by both. How about 9? Is it invited by both? No, 9's not invited by both because that's open. 9's only invited by B. So this is open. How about 10? Is it invited by both? And 11 and 12 and 13? No, it's only invited by one, only invited by B. So the things that are in the intersection where they intersect one another, right? Intersection, where they intersect one another is the things in between. And so A intersect B is equal to, in interval notation, parentheses, because open circle, 7 over 3, comma, that's where the solutions start. Where do they end? At 9, and parentheses on 9. And so that's A intersect B. So we did a lovely job on that. I'm going to go see what my family has whipped up for dinner, and then I'm going to come back and do the other video and put it up online for you to do. I hope that you're doing homework, my friends.